Let me show you the final result first. Hello everyone, I have installed a pair of Denali S4 pod lights on my Transalp 750. This video is not about how well they perform. They're great. There's plenty of videos showing how they perform. This is more about the installation process. So I wanted a few basic things. I wanted the lights, the pod lights, to be fully integrated with the bike's controls, and I wanted to have the possibility to turn them on and off on the go. There's been a few challenges with the installation, so that's mostly what this is going to cover. And if you're not too keen on the whole process, I've made a friendly wiring diagram, so you can jump over to the end of the video and you'll find it there. What else? Denali S4's LED light pod, switch eliminator, DataDim Controller, dual intensity to switch 50% intensity to 100%. I could have gone for the dial dim instead, but I don't need all that fancy stuff it does. Harness, and I got these from AliExpress. They're actually quite good. So they're made of aluminium, so I'm happy with them. Okay, so here's the deal. This is what I want to do. Okay, I want these integrated with the bike. So this is the ignition switch. Of course, you turn the key on and the low beam turns on. And here is the high beam or full beam switch. So you turn it on, it turns on. Somewhere there's a connector, something like this. I think it's gray, where I'm going to get the signal to synchronize the pod with the full beam. And somewhere there's another connector, like this one, for the auxiliary lights, for the fog lights, which is controlled by the settings. So, high beam plug. Okay, so pods. The dashboard is off. So when I turn the ignition on, they shouldn't go on. Let's see. They didn't. Okay, if I turn the dashboard on, I mean the fog lights on the dashboard, they go on. The fog lights are on the dashboard. When I turn them on, they go on. Full beam. I can turn them off on the dashboard. Okay, here's the bike stripped down. This is where the auxiliary lights connector should be hidden there. Okay, so there's two connectors here, protected by this rubber casing, and this one is probably for the heated hand grips, and this one is for the auxiliary lights. And you can see there's two wires. So green is ground, blue is live or positive. So green is negative, blue should be positive. And there's a dummy here. There's a dummy there. Let me show in detail the plugs or the connectors. So this one, blue and green. This one is for the auxiliary lights. And this one, yellow and green. This is for the heated grips. Okay, so pods connected. So I've got the pods connected here. I'm going to do a test first. We're going to connect these to the battery soon. And here's the trigger wires. So the white one goes to the auxiliary lights and the blue one goes to the high beam. And the high beam connector should be the blue one. can see the blue one. Can you see it? No. You can see now. Looks kind of green. But there's the blue one. There. Okay, so that blue one should be a high beam wire. But before, I'm going to run a test here. I'm going to turn it on. And I'm going to tell the bike that I want to turn the fog lights on. So service connector there. I'm going to stick one wire on one side of that connector, on the red one side, and on the other side. Sorry, it's difficult to do with one hand only. So on the other side, okay, just wire up like that. And now I can come here and go to settings. This is very bright. Go to assistance, maintenance, equipment, and now the fog light can be switched on. Okay, so it is on. We got on. So I go back. Just go back. Turn it off. Remove that. And now this guy here should be energized when I turn the key on. Let's see. Alright, many hours later, this is what I've done. So the dual dim is here, the DataDim is here, and this is how I've connected to the batteries. Negative, I've used the strap holding the battery to hold the fuse. Okay, and I managed to feed the wires under the tank. There's a gap there. Didn't remove the tank because this is a pain in the bum cheek. To remove everything, the air filter is actually over here. It's very difficult to get access to it. So to remove the tank, I would have to remove a few more bolts there. I'm not going to do it. I managed to feed the cables underneath there, and I've chosen the left side of the bike because there's these holes where you can feed the wires through, and there's the auxiliary light connection here, and the white wire is plugged to the positive pin over there. Okay, turn it on. Okay, so we can go here. Function. And turn it on. And they turn on. Okay, so I can turn the lights on and off using the dashboard. What I can't do is to find signal for the high beam, because that blue wire over there, so you have a blue one, gray one, and on the upper side you have two black wires and a green one. So green is ground, and these two black wires are constantly 12 volt. constantly 12 volts, and this blue one, which I thought it would be the high beam or the full beam, it doesn't work. It's actually, it comes down to 0 volts when I turn on the full beam switch. Strange, so I don't know how to wire this. A few weeks later, while I waited for a few things to be delivered, and after doing some research, I came up with a plan B. So I didn't know that on the Transalp and also on other bikes like the Africa Twin and the Yamaha D7, they all work the same way. I didn't know that the headlights are ground switched, which means when we flick the high beam switch, that wire we should tap in order to feed. So that wire we should tap in order to feed the blue wire running into the DataDim doesn't supply 12 volts. So in that case, we have to do something else. And actually Denali has a solution for that. They've got a trigger wizard, which I couldn't find in stock anywhere. So I'm going to do my own. So we need a relay. We need a 4-pin relay. And for that, I ended up ordering like a normal, not normal, micro relay, Bosch one, 4-pin relay. So I ordered this, €3.50, something like that. But then I thought about the relay that comes with the Denali original harness. So the DataDim replaces this one. So I'm going to be using this one. This is the one I'm going to be using. So I've removed this connector here, and I'm going to be using the relay that comes with the Denali harness. Okay, and this is how it works. So you have the white wire, which is switched power. So when we turn the key on, it feeds 12 volts through the white wire. It makes the fog lights, the pods, to work on 50% intensity. When we feed the blue wire with 12 volts, there's a relay in there that switches to 100% intensity. So how do we make this wire to get 12 volts? Okay, so we should be looking into the headlights connector. Just disregard the top side. So on the way out, the colors of the wires are different, but that doesn't matter. We need to look into the bottom side of the connector. And this is what we have. So we have on the bottom, we have a green wire, that's ground. 2 black wires, those are constant 12 volts. And on the top we have the blue wire is the high beam, and a light gray wire, that one is the low beam. And this is how we wire the relay. So I'm going to get the 12 volts to feed the wire. I'm going to get it from the auxiliary lights connector. Okay, so on the relay, on the pin number 85, I'm going to connect 12 volts coming from this connector here. Okay, and we're going to split in two, and we're going to feed the pin number 30 with 12 volts as well, knowing that this is not going to do anything just yet. So energy goes to pin 85, but at the same time down to the white wire. When I turn on the key on the bike, I've got 50% intensity. And then on the pin 86, I'm going to connect the high beam wire to the pin 86. And what it does is when we turn the high beam switch on, okay, so when it's off, the voltage there is different from 0. But when we turn the high beam switch on, it's 0, which means it opens up the circuit here. So energy flows through, energizes the coil, and then 12 volts will go up to the 87 and down to the blue wire. So we're going to wire up on the 87, pin number 87. We're going to wire it up to the blue wire on the DataDim. I hope it makes sense. Okay, let's see what I've done here. 12 volts coming from the auxiliary light connector. It's connected to only one side. So this wire here will then split in two. And this pin is the 85. And that pin is the number 30. And also the white wire coming from the DataDim is plugged over there. So I always have current when I turn on the key. In there, I ended up tapping the blue wire. Initially I didn't want to, but it's a pain in the bum cheek to produce one of these because these wires are very tiny and I don't have them. I didn't have them, so I ended up tapping and it's done. Okay, so this blue wire, that's the high beam, is connected to the 86, pin 86 on the relay here. And in the middle there, there's the pin 87 that runs down to the DataDim through there. So, keys on. And here goes nothing. So 50% comes on. Now, moment of truth. Let's see if when I flick this guy, if it goes full intensity or not, or might just blow up. I don't know. Let's see. Aha! It works. I was in a bit of a rush and I had to put everything back together. I've insulated the wires and I have managed to tuck everything properly, either behind the screen or under here. There's a space, there's a pocket where you can tidy up everything very nicely in there. Later that day, at night time, I went for a spin with the bike to test the lights and I'm very happy with them. The full beam is very bright, very powerful. I'm very happy with it and I'm going to show you how it looks like now, and everything is synchronized with the original switches as I wanted to. So, bike is on and no engine check light popped up, so everything is working. So you can see they come on, synchronized of course with the low beam, and when I flick the high beam or full beam switch, both come on. However, So you can see it's working, and you can also see the full beam indicator comes on there. But now when I go to function, and I turn off the fog lights, I turn them off and I flick the high beam or full beam switch, the indicator of the full beam comes on, but the actual full beam LED doesn't when I turn them off. I'm not too bothered about it, but I want to be able to switch off the fog lights and still use the headlights fully, and I can't. So back to the diagram, and I'm going to think what might be wrong here. So this is what we have now. Okay, so this one is positive, this one's negative, and this is what's actually going on. So energy coming from the auxiliary lights connector when I switch the bike on and I turn the fog lights on the dashboard. So energy, okay, current. Okay, let's talk about current. Current flows through there, pin number 85. It doesn't matter where the positive and the negative go on this relay. It can go, the positive can go either on the 85 and the negative on the 86, or the other way around. It doesn't really matter. The relay I have installed on the bike is the one that comes with the Denali. It's exactly like this one. Just disregard the numbers of the pins, and it doesn't really matter because it has that symbol there on the top. It means there's a resistor protecting the circuit. So when we de-energize the relay, the magnetic field collapses and produces voltage that can go to the positive side, can go backwards and damage the circuits. So that's not a diode, that's a resistor. So it doesn't really matter where you plug what. Okay, so that's not an issue. Okay, current goes through there onto the 86, all the way down to this wire, okay, where, this is the high beam wire. So there's current flowing, and therefore the high beam, the full beam, is on, because there's, this wire here is properly grounded. When I cut the circuit, when I turn off the fog lights on the dashboard, there must be something in the circuit here that is preventing this wire coming from the LED, the full beam LED, to properly ground so it doesn't turn on. This is what I think is happening. So the voltage on this wire should be 0. So this wire would, work towards ground, but something is preventing that to happen. Okay, so what can I do? I'm going to run a few tests. I'm going to disconnect the battery. I'm going to disconnect the DataDim and the Denali harness from the battery to see if, when everything is disconnected, if the headlights work properly. If it works with the harness disconnected, that's the issue. So there's some voltage here preventing this wire to ground. And if the issue is that, I don't have the solution for that. I'll probably have to think about how to stop, maybe with a diode. So when the circuit is closed here, so when there's no current there, and I still want to use the full beam of the bike, okay, and this wire needs to be properly grounded, I need to prevent any current, residual, I believe, current to flow this way. So I might have to put a diode there. So when this is on, current will flow everywhere and down here, and this wire is grounded properly. But when I cut the energy there and I use the full beam switch, this will be grounded because there's no current going towards that way. Let me know. I don't know. Here we are in the guts of the Transalp 750 again. I've disconnected this blue wire. This is the wire that is connected to the pin number 86 on the relay, and I've put the relay here. It's taped with self-vulcanizing tape to protect it a little bit. This one is the 12 volt socket connector. By the way, I've used one of these. So I've used one of these. Anyway, that's for another day. So this is the posit tap. It's tapped into the blue wire. It's disconnected. That works. And for peace of mind, nothing wrong with the high beam on the bike when this guy is disconnected. So there's some noise between this one and the relay. So when I put it back together there, the full beam of the bike doesn't work, and I have to wrap my head around it to figure out why. I don't know why yet. This is what I've done to troubleshoot this problem. Full beam doesn't go on when there's no power here. So I have disconnected the harness from the battery. Still, full beam on its own doesn't go on. I have swapped these pins here. I knew it wouldn't change anything, just for peace of mind I did it. So now the positive is on the 86 and the negative is on the 85. Still doesn't work. The length of this cable here was short and the cable was very thick. I have swapped this cable for the thinner one. It doesn't work. So there's just one last thing to do. I don't know what's going on here on this side of the circuit. There must be, when this is off, when I turn this off, there must be some current still, which is, deviating the electrons to, towards that side. So the last thing to do is to place a diode here. So that's what I'm going to do now. I'm going to place a diode there to prevent the electrons flow backwards. Let's see if it works. Same connection, no diode yet. Just checking if it works. Still. Yeah. All good. So I'm going to place the diode now. It should work the same way. Let me see. It does. Diode works when everything is connected together. So the fog lights are on and the Denali work perfectly with the diode, like forward biased that way. Turn off the fog lights on the bike, and if the diode works, I'm going to flick this guy here and the full beam of the bike should work. It does. I'll be damned. It does. Problem solved. Cool. Full beam works. Fog lights on. Both work. And that's because of this guy here, the diode. And to wrap up, let me tell you why I chose this diode. A Schottky SB1540, 40 volts, 50 amps. Why a Schottky diode? These diodes, compared to normal diodes, the forward voltage drop is not massive. Okay, in this case, the maximum forward voltage drop is 0.5 volts because the diode will hold some voltage when the current is going through. So that's one of the reasons I wanted a small voltage drop, and also because of that, these ones don't get hot. There is though some leakage when current is trying to go that way. These tend to leak more, but for the purpose, because we're dealing with small amperage. That doesn't happen, and this works fine. So that's why I chose this one. And that's a wrap. So plan C worked. Happy days. One last comment about the whole project. The engine check light did come up a couple of times. The first time when I was searching for 12-volt signal in the headlights connector, I made a short, and of course the headlights fuse blew up. I've replaced it. There's spare fuses in the fuse box. I have replaced it immediately, but the engine check light was still on. The following day I went to work. I rode to work, and by the end of the day I went to Honda. And when I got there and I asked them to check what was wrong, when I turned the bike on so they could check, the engine check light wasn't there anymore. So the problem was sorted out. They still connected it to the computer, and the error message was miscommunication in the CAN bus. So because of the fuse, because of the fuse because the fuse blew up. No problem. Second time, again when I was wiring everything in the dashboard, I had to disconnect the dashboard, and then when I was testing everything, I ended up turning the bike on without the screen, and that also made the engine check light to turn on. So when I put it back together, the engine check light was there. So I didn't do anything. I didn't go to Honda this time. And a couple of hours, I rode the bike for a couple of hours. You turn the engine of the bike on and off, a few times. And because the problem isn't there anymore, the engine check light just turns off. Okay, so of course that was before this last thing I did with the diet. Okay, the diet is working, no engine check light, the lights work properly, so I think I didn't do anything wrong. But please, if you think otherwise, if you think I'm doing silly stuff to the bike, if I'm putting the bike at risk or damaging anything, let me know. Make comments, okay? Ask questions. I'll do my best to get back to you.